In this video, I'm going to be talking about function notation. Now, function notation is just another way that we can write functions, and it's a way that we can name functions. So, for example, this equation that looks really familiar to us, y equals 9 minus 4x, that represents a function. Now, you can use the letter f or any other letter to name this function, and then use function notation to express it. Just replace the y with this symbol right here. Now that symbol right there, it's read as f of x. Now f of x means the output value of the function f for the input value of x. I would read this equation as f of x equals 9 minus 4x. Now the f of x is equivalent to a y value. So wherever I see a y, I can replace it with f of x. Wherever I see an f of x, I can replace it with y. So in this example right here, when I see y equals 9 minus 4x, it would be totally acceptable to rewrite this as f of x equals 9 minus 4x. When we read that, those are exactly the same equation. That's exactly the same function. Now that letter F that I chose to use, it just is the name that I'm choosing to use for that function. I'm just out of the blue choosing F. Most of the time, math people choose the letter F because we are actually referring to a function. So because function starts with the letter F, we usually use F. And then after that, if we have multiple functions, we just go down the alphabet. So the next function we would probably talk about is g of x, and then h of x, etc. So right now, it's just a letter that we just choose. If you really love the letter A, then it could be a of x. It doesn't really matter. So again, you can choose any letter that you want. Math people usually start with the letter F because we're actually referring to a function. Our x value that you see inside these parentheses, that's the input variable. So most of the time we're wanting to know, when I put this number into the equation, what is the output? Something I want to point out is in function notation, the parentheses do not mean multiplication. We are not solving for the letter f. We are actually going to be either solving for x or we will be solving for that big symbol f of x. And I'm about to show you what that looks like. In this really preliminary example, I'm giving us f of 2. So it's asking me to find f of 2 in the given equation. So here's our given function, obviously 9 minus 4x. And they want me to input that 2. So right here, they've replaced this x with that 2. And so they kind of want me to do the same thing. Here's an x, and so they want me to take that x out and replace it with the 2 and then do the math. So 9 minus 4 times 2. Because of order of operations, we do that 4 times 2 first, which is 8. So really this is saying 9 minus 8 is 1. So my answer to this is f of 2 equals 1. When you input a 2 into this function, your output is going to be a 1. Now we can also, this is a totally acceptable way of writing it. We could also write it as a coordinate point. The input is your x value, obviously. We replace that x with 2. So in a coordinate point, we can put that in the x location, that 2 in the x location. Now your y value would be your output. My output in this case is going to be a 1. Again, don't forget that y and f of x are exactly the same thing. And so when I see this, f of 2, or whenever I put 2 into the function, a 1 is left over. That 1 would be my y, or my output. Let's practice some more. In our first example here, it says given f of x equals 7x minus 1, find f of negative 2. So in my equation, I'm actually going to replace this x with negative 2. Now, if I replace that x with negative 2, I have to replace this x with negative 2. Notice when I replaced that x with a negative 2, I replaced it and I used parentheses to show that's where I'm putting it in. 7x means 7 times x. So when I replace that x, it would be 7 times whatever I'm replacing x with, and in this case, I did a negative 2. The parentheses perfectly show multiplication in this case. So once I replace that, then I just do the math. So 7 times negative 2 is negative 14, and negative 14 minus 1, that's negative 15. So when I read my answer, I would say f of negative 2 equals negative 15. This is a really great answer. You can write it like that, or you could also write it as negative 2 comma negative 15. My input or my x value was negative 2, and the output was negative 15. Let's try another one. So in this one, g of x equals x squared minus 4. They're asking us to replace the x with negative 5. So I'm going to go to the right side of my equation and I'm going to replace that x with negative 5. Again, when I replaced that x with a negative 5, I'm using parentheses. And in this case, it's really important that we use parentheses because when I square negative 5, that's going to be a positive 25. Your calculator, if you get to use one, if you just typed in without parentheses negative 5 squared, it would give you a negative 25 as an answer. And we don't want to have any mistakes like that, so please use parentheses when you input your values. So, like I was saying, this negative 5 squared right here is actually going to be positive 25. And when I do the math and I do 25 minus 4, my answer is 21. This is an acceptable answer. It's really great. And I read it as g of negative 5 equals 21. If I want to write it as a coordinate point, which is another acceptable way, I would write it like this. My input, or the x value, was negative 5, and my output, my answer, was 21. Let's do another one. This one is a little bit different. Notice that it says h of x equals 9. So that means that I'm going to replace that h of x with 9. It's going to look like this. And now I'm going to solve for x. They want to know what is the input when the output is 9. So what did you put in to this equation to have your outcome be 9? So let's solve and find out. So I'm going to go ahead and move my 1 across by doing opposite operations. 9 plus 1 is going to be 10. And now I have 10 equals 5x. To get x completely by itself, because you're multiplying there by 5, you're going to go ahead and divide by 5 on both sides. When you say 10 divided by 5, you get an x value of 2. This is your input. You can write your answer as x equals 2. You could also say, h of 2 equals 9. As an acceptable answer. And you could also say, since your x value is 2 in a coordinate point, you could say 2 comma 9. Let's do one more example together. This is sort of our same scenario where they say, given f of a equals negative a plus 2, find a when f of a equals 6. So what we're going to do is we're going to recognize that f of a and 6 are equivalent. They're synonyms. You can replace an f of a with 6. Since I see an f of a right here, I'm going to go ahead and replace all that with 6. And I'm going to go ahead and solve. So I'm going to go ahead and do opposite operations and move that 2 to the other side. And when I do that, 6 minus 2, that's going to be 4. Now 4 equals negative a, and we can't have it be negative a. So we need to get a completely by itself. One way to do that is to recognize that that's a negative 1 in front of your a. We're going to go ahead and divide by negative 1. And when we do, 4 divided by negative 1 is going to be a negative 4. And negative a divided by negative 1, those are going to reduce out and just leave us with a. So our answer is going to be a equals negative 4. Now this is an acceptable answer, and it's probably a good one that we talk about. This statement says when the output is 6, they're asking what is the input. So we could say f of negative 4, because my a value is negative 4, and I can replace that, equals 6. This is a great way to write your answer. Another way that we can write our answer is that we understand that this is our input, or our x value in a coordinate point, and our output is going to be 6. So that's another really great way that you can write that answer. So now what I want to know is what challenged you in this lesson. Also, what are some things that you need to know for sure moving forward?